Hi folks, this is the solution for 6b on page 82. So they want us to determine f prime at a for this given function and for a equals 64. Okay, so essentially what they're giving us here is the x value for which we want the derivative of that function. Okay, now in the past what we would have done is we would have used the limit definition and determine, the limit as h approaches 0 of f at 64 plus h minus f at 64 all over h. Okay, except now what we can do is it's much easier to just find the derivative function, and then once we have the derivative function, input a equals 64. So that's what we'll do here. So I'll start by finding f prime at x. Okay, now this is an important little thing here, is make sure you don't input the 64 before you find the derivative, because if you just input the 64, you're just going to end up with a constant, and you take the derivative of that, you're just going to get 0. Okay, so here first you have to find the derivative function and then input the x value that you're interested in. Okay, so again, we can split this up into 3 different derivatives by using the addition and subtraction rules and then using our constant multiple and our power rules. Okay, so here derivative of 7 is just 0, so no need to write that out. So here now we have the derivative of negative 6x, so we have negative 6 is my constant, okay, and I can multiply that by the derivative of square root of x. Okay, now at a certain point you won't be writing this down. You should be able to just determine that derivative right off the bat. Okay, but for now I'll write that I'm finding the derivative of square root of x, which of course you're going to think of as x to the 1/2. Okay, then we've got plus, again 5 is just a constant, so the derivative of this expression is just 5 times the derivative of x to the 2/3. Okay, so let's start calculating this. So negative 6 times, so the derivative of x to the 1/2, so remember the exponent becomes the coefficient, 1/2 times x, and we have to subtract 1 from the original exponent. So 1/2 minus 1 is negative 1/2. Okay, so plus 5 times, so again we have a power of x, so the 2/3 becomes our coefficient, okay, and then our exponent goes down by 1, so 2/3 minus 1 is negative 1/3. Okay, and so now we could stick in the 64 right now, but I think it'd probably be better if we simplify a little. So here negative 6 times 1/2, so negative 3, and here x to the negative 1/2 we'll write in the denominator as square root of x. So the negative brings it into the denominator, and let me write as a square root because that's more familiar when I'm actually substituting in the number. Okay, so plus here we have 10 over 3. Okay, and again this negative is going to bring this power to the denominator, and exponent 1/3 is the same thing as cube root. So 3 times cube root of x. Okay, so now at this point here, I can determine f prime at 64. So this represents the derivative of the function f at x equals 64, and we'll just input that into our equation. So 3 over square root of 64 plus 10 over 3 times cube root of 64. Okay, so here square root of 64 is 8, so we have negative 3 over 8 plus 10 over 3 times, well, the cube root of 64 is just 4, so 3 times 4 is 12. Okay, so let's put everything over one denominator. I guess 24 will be the way to go. So this will be negative 9 over 24 plus 20 over 24, and negative 9 plus 20 is 11. Okay, so there we go. There's our final answer. So again, what does this number represent? This number represents the slope of the tangent, or the rate of change of this function f, okay, when x is equal to 64. Okay, that's it for this one.